A survey of daily travel time in the North Carolina Research Triangle Park shows on average folks spend 63 minutes per day in the car with a standard deviation of 23 minutes. However, people in the Charlotte area spend 58 minutes per day in their car on average. It should say on average, with a standard deviation of 16 minutes. So we're assuming the data is normally distributed. In which area are folks more likely to spend less than 30 minutes in your car? So you're going to need to use either the empirical rule or z-scores and actual numbers to support your answer. If you just write Charlotte or the Research Triangle Park, that's not showing us that's not showing a thought process that involves math. So we need to see your thoughts about the math behind this question. We want to know if you can answer this question using the math you've learned. So I'm going to draw a sketch of RTP, right? So I've got 63 minutes per day here, and then a standard deviation of 23, so that's 86, and 109, and then 40, and then 17. I could go one further out, but what I care about is the 30-minute mark, right? So the 30-minute mark's going to come here, right? Now, Charlotte, '58 here, and it's got a standard deviation of 16, so one up is 74, and then another up, 90, and then one down is 42, and another down for 42, 16, 26, right? So again, I can go one more, but what I care about is right here, right? So just looking at this from my sketch, it looks like you want to know how many folks are likely to spend less than 30 minutes. You want to know about this shaded area, right? And if you notice right now, just from the sketches, 30 right here comes closer to the first standard deviation of RTP, whereas 30 right here with Charlotte is further away. So just using the empirical rule, I would be able to say, well, it looks like there's a bigger percentage right here for the RTP that's less than 30. However, let's go ahead and use z-scores just to be sure that my sketch isn't off or that I didn't entirely do the math wrong when I did this. So how to use z-scores? Again, you just need to find what that actual percent is that I'm shading. So here's 30. Here's 30. I need to find how far away it is from the mean. So that's 33. And I need to divide by the standard deviation, 23. 33 divided by 23, 1.43. So that's the z-score. Oh, and now I'm realizing, wait, that's positive. It shouldn't be positive because it's on this side, so it should be negative. That should be a negative 33. So just keep your eye out for that. If it's on this side of the mean, your z-score should be negative because we're going down below the mean. Okay, and over here, 30 is 28 away from the mean here. And then divide by the standard deviation. And again, it's 28 on the negative side. So negative 28 divided by 16. So 28 divided by 16, negative 175. So this is the z-score here, right? And then if we were to look at our z-score chart, go to negative 1.4, and then over to negative 1.43 right there. That's 7.6%. So 7.6% of people in the RTP are in their cars for 30 minutes or less. But in Charlotte, we've got negative 1.75. So negative 1.7, and then over for the hundredths, 5. So that's 4.01%, so about 4% for Charlotte. So in Charlotte, only 4%. So which area are folks more likely to spend less than 30 minutes in their car? In the RTP. So this is something that's important to know, because if all you knew was these averages, it would look like, oh, the Research Triangle Park was a much worse place to be because they're spending a little bit longer in their car on average. However, because that data is a little more spread out, there is a better chance that you might spend time in the car a lot less than that. There's also a better chance that you spend a lot more than that in the car. So it's just a reminder that the standard deviation really does impact what people's lives look like. So it's more like in the RTP, there's more difference. So some people are in their cars for a really long time. Some people aren't in their cars for very long at all. Whereas in Charlotte, people are much more likely to all have a similar commute time. So RTP is the answer. This work right here shows your work. You don't have to explain it in words if you can see this kind of stuff.